Hi friends! So we are going to learn how to use video physics, which is an application that should have been pushed out to you by self-service. There are two different applications that we'll need for the activity today. The first is video physics and the second is graphical. So make sure you download those from self-service before you get started. There is a strange interaction that happens between graphical and video physics. So one thing that you always want to do before you get started working in video physics is open up graphical. Now, it doesn't mean that you have to have something started, but you just need to open the application. Once graphical is open, go ahead and open video physics. So here we will start a new experiment. To upload a video, tap on the plus sign in the top left. Tap on Choose Existing Video and select the video from your photos. So here I know that the ball toss video is my first video there. I'll just go ahead and double check. That looks good, and I will select Use. So video physics has already opened up a new experiment. I will go ahead and advance the frame until I just see our object. So here I'm advancing the frame until the ball leaves the person's hand. So remember, we don't ever want to start collecting data for right now when the object is still in the person's hand. So I'm advancing frame by frame until the ball is no longer in contact with our person's hand, and that looks good to me. The next step is to make sure that you set your origin and scale. So in order to do that, up at the top center of your screen, you see that there's an option for origin and scale, and I will go ahead and tap that. Now here I'm going to move my origin so that it is right at the bottom of my object. So I set my origin so that it is at the bottom of the ball. And I also need to set a scale. So I need to tell the program exactly how long 1 meter is. So with this movable measurement stick here, I'm going to align the end of the white line with the top of the meter stick, and then I will move the bottom of the white line to the bottom of the meter stick. So here you can see that we're telling the program that 1 meter in this video is 452 pixels. I've set my scale, I've set my origin, and so now I'm ready to collect data. Tap back on points at the top center of your screen, and now you can begin collecting data just like we did in the Pivot Interactives. So before I gather data, there's something I want to do. I want to change the size of my selector to minimize it because I see that my ball is very small. So if I toggle between the positive and negative sign, or the plus and the minus, I can change the size of my selection tool. I can also zoom in here on the video. So I'm going to zoom in and enlarge the video so that I can make sure that I'm collecting the most accurate data I can. So here I've aligned the bottom of my selection tool with the bottom of the ball. Every time that I tap to collect data, video physics will automatically advance the frame of the video by 1 frame. Now let's say I make a mistake. Let's say I tap there and I don't like that. Then I can move my selection tool. I can hold down on this point and I can select it and I will click delete. If you delete that point, you want to make sure that you rewind the frame of the video. So now I'm back to where I was and I can continue going. You can continue to adjust the frame of the video so that you can more clearly see what's happening. Here it looks like our object is momentarily suspended in the air before it starts to move back down. All right, so for our data, I am going to stop collecting data around the same height at which I began collecting data. I can move my cursor to the side, minimize my video, and now I can see that I've collected a lot of data points here. Now, video physics does have the ability to create its own graphs. So if you were to click on the graph icon on the top right, you would see that you could look at your data graphically. Video physics does have a few limitations, and because of that, we are going to actually export our data and open it up in Graphical. So in order to do that, click on the box with the arrow in the top right. At the bottom, you see the option to export a graphical analysis file, which is a .ambl file, and I will select that. I'll scroll to the right, and hopefully I see Graphical. If I don't, I can click Open In, and then I should see Graphical here. Okay, so I can see Copy to Graphical. I will tap there, and now I can see my data. So now I see my data in Graphical. One of the first things that I want to do in Graphical is tap on the experiment name on the top left and click Save. So I'm going to rename this Ball Toss Data, and I'll save that. So I just want to make sure in case anything happens, my data is saved. Now, it's not particularly useful for us to look at both X and Y data on the same axes. And so in Graphical, if you click on the axes, you can toggle different sets of data on and off. So for the start, I will toggle off the Y data, the Y position, and on our velocity graph, I will toggle off the Y velocity. So here I can see what's happening in the X direction. It doesn't look great. You can see that there's some variation in my data. So let's see what's happening in the Y direction. So I'll tap on my axes again, turn the Y position on, turn X position off. On the velocity graph, tap on the Y axis, turn X velocity off, turn Y velocity on. So here I can clearly see my Y position as a function of time represented by the red graph, and I can see Y velocity as a function of time represented by the yellow graph. Now, because we are not yet talking about two-dimensional kinematics, we are only going to look in one direction for now. So for the ball toss video, we are just looking at Y position and Y velocity. If I wanted to apply a curve fit to this line, meaning the Y velocity, I could. And there is a curve fit button on the bottom left of your screen that looks like an axis with an applied curve fit. So I'll tap on that button here, bottom left, and I'm going to choose Apply Curve Fit. The curve fit I'll select is linear, and when I press Apply, I'll see my line of best fit data. So you can see in this data box here, it shows me my slope of negative 9.707 meters per second squared. It shows me my deviation or accuracy, and it shows me my y-intercept. I could also apply a curve fit to our parabolic graph of y position by doing the same thing. So pressing on the curve fit button on the bottom left of our axes, selecting apply curve fit, but this time this is clearly not linear. So I might apply a quadratic curve fit, and here I can see some other data about this line of best fit. Now, in order to capture this data, I will take a screenshot. So my screenshot button is enabled on my iPad, so I will just hold down on my button and capture a screenshot. When I go back to video physics, you will see that your data is still saved, and this experiment is automatically saved for you as experiment 6. So when I tap back on experiments, I'll see that experiment 6 has been automatically saved in video physics. Now remember, this was not the same in graphical analysis, and so I had to personally save my graphs in Graphical. Once you have your screenshot from graphical analysis, you can make sure to put this into your assignment.